Chapter 4.2 is solving systems of linear equations by substitution method. So let's work a couple of problems from the Chapter 4 review found on page 339 in your textbook. Alright, so chapter number 15, my system of equations. So I have 2x minus 3y equals 7 and y equals 3x minus 7. So the name is substitution method because how you're going to solve the system is by using substitution. So the first thing you want to do is solve one of the equations for one of the variables. Now, I'm going to call this equation 1 and call you equation 2. Equation 2 has already been solved for y. So step 1 is taken care of. And then step 2 says take the solved equation and plug it into the other equation. So everywhere I see a y, I'm going to plug in 3x minus 7. So I have 2x, let's change the color. So I have 2x minus 3. Instead of the y, I'm going to write 3x minus 7 equals 7. All I did was rewrite this first equation, and everywhere I saw the y, I put 3x minus 7. And now the last step is to solve for the variable, not the last step, I take that back. The next step is to solve for the variable. So I have 2x minus 9x plus 21. That's because I distribute the negative 3. So I get negative 3 times 3x is negative 9x. Negative 3 times negative 7 is positive 21 equals 7. And let's solve for x. Put your x's together. So I have negative 7x plus 21 equals 7. Now to solve for x, I'm going to subtract 21 on both sides. And I get negative 7x equals negative 14. And then I'm going to divide by negative 7. Divide by negative 7. And I get x equals 2. But I'm not done. I still have to find y because my solution is an ordered pair. Your solution is an ordered pair, which means it's an x, comma, y. So I know x is equal to 2. How about we use equation number 2 to find y? So I have y equals 3 times 2 minus 7, which is negative 1. So my solution is going to be, where should we write it? Right here. 2 comma negative 1. And remember, the solution means if you plug this back into either one of these equations, they will work. They'll actually be true. Good. Let's try number 17 because it's a little different from number 15. In number 17, I still want to solve my system of equations by substitution, but step 1 was not done for me. So I have to do that. Step 1 says solve one of the equations for one of the variable. So let's see here. How about, let me again label this equation 1 and equation 2. How about we solve equation 2 for y? Since its coefficient is a positive 1, it's less work. So I have 3x plus y equals negative 7. Subtract 3x on both sides. And I get y equals negative 3x minus 7. Cool. And then step 2 said take the solved equation and plug it into the other equation. So let me do that. So now I'm going to take this y, and everywhere I see a y up here, I'm going to plug it in. So now I have 2x minus 5 times negative 3x minus 7 equals 1. And now I get to solve for x. So I have 2x plus 15x plus 35 equals 1. Again, put your x's together. 17x plus 35 equals 1. And let's solve for x. I'm going to subtract 35. And I end up with 17x equals negative 34. And then I'm going to divide by 17. And I end up with x equals negative 2. Okay, but you're not done yet. We still have to find y. So now I'm going to take this x and plug it into any of those equations to find y. I'm going to choose to plug it into this one because this one's already solved for y. So I'm going to have y equals negative 3 times negative 2 minus 7, which is going to be y equals 6 minus 7, which is negative 1. So I get y equals negative 1. So my solution is negative 2, negative 1. Now you should really check these, right? And how do we check our answers? Just plug it back in to the original system. Plug it into the first equation, make sure it works. Plug it into the second equation, also make sure it works. Do the same thing here. Plug it back in into the original system and make sure both equations work. Okay, now let's work on numbers 20 and 21. Number 20. I'm still going to use substitution. So I have 4x plus y equals 5 and 12x plus 3y equals 15. And when I use substitution method, the first step I have to do is solve one of these equations for one of the variables. So let's call this equation 1 and call this equation 2. Again, I see that the coefficient in front of y in the first equation is a 1, so I'm going to solve the first equation for y. So subtract 4x, and you end up with y equals negative 4x plus 5. Awesome. Then step 2 says take the solved equation and plug it back into the other one. And the other one's equation 2. So I have 12x plus 3 times, now instead of writing the y, I'm going to write negative 4x plus 5 equals 15. And I'm going to solve this equation for x. So 12x minus 12x. One second. Alright, so I have 12x minus 12x plus 15 equals 15. Now remember, you got to distribute the 3. So that's how that became a negative 12x plus 15. What happens to the 12x and the minus 12x? They cancel each other out. And I'm just left with 15 equals 15. Now, is this a true statement? Is this true? Yes, it is actually. It is true. 15 does equal true. So what is your solution, though, to your problem? How many solutions do you have? You have infinitely, let's make sure I spell that right, infinitely many solutions. All right, let's look at number 21. So now in 21, I'm still going to solve using the substitution method. And it just so happened that the second equation was already solved for y. So I can skip the first step. The first step says to solve one of the equations for a variable. Well, this one's already solved for y. So I'm going to go ahead and go to the second step, which says take this equation and plug it into the first one. So I have 4x minus 2 times 2x plus 3 equals 10. So now I get to solve for x. I get 4x minus 4x minus 6 equals 10, because I distribute the negative 2. Good. Now what happens to the 4x and the minus 4x? They cancel each other out, and I'm left with negative 6 equals 10. Now, is this true? The answer would be no. Negative 6 cannot equal 10. Therefore, for this problem, what would be my solution? Well, I don't have one. It's no solution, or it's the empty set, or literally it's the empty set. Okay, so let's recap quickly. In both of these problems, towards the end, when I'm solving for x, I eliminated the x, and I was just left with a statement. This one said 15 equals 15, and this one said negative 6 equals 10. Well, 15 equals 15 is a true statement, so I have infinitely many solutions. There's multiple of them. And why is that? Why is that? That's because if you look up here, you see this 4x plus y equals 5. And then the other equation is 12x plus 3y equals 15. Do you notice the relationship between these two equations? The second equation is the first equation multiplied by 3. What's 4x times 3? It's 12x. What's y times 3? It's 3y. What's 5 times 3? It's 15. It's the same equation. Therefore, when you graph them, if I can pretend like I'm graphing them, in fact, I'm not going to pretend like I'm not going to graph them. Let me just say it. So when you graph them, they actually lay on top of each other. They're the same line. Therefore, how many places do they actually intersect? Infinitely many places, because they're laying right on top of each other. Number 21, well, I ended up with -6 equals 10. That's not true. So my solution is no solution. So if I was to graph these two lines, they wouldn't intersect anywhere. Absolutely nowhere.